Using the index and match function. The debate on which is better, VLOOKUP or index match function, has been going on for quite some time. As a matter of fact, users are rather confused about which one would be a better fit. So here's what we're going to do. We're going to lay down the facts for you, plain and simple. You can then figure out which one is best. Remember, this is very subjective and thus choosing either of them wouldn't be a wrong answer. Let's jump right in. What is the index function? The index function is a reference function that returns the reference of a value from a cell, table, or range. This function is not limited to references but also returns a value based on the need of the hour. The index function syntax. We've clearly outlined that the syntax function has multiple use cases, and based on these, we have two forms of the index function. 1. To return the value of the cell we have equals to index, open parenthesis, array, comma, row underscore num, comma, open square brackets, call underscore num, close square brackets, close parenthesis, where array is a required parameter and can be used for two cases. 1. Where there's only a single row or column, and 2. Where there's an array of rows and columns. Depending on which one is applicable to our sheet, we need to add the row underscore num and open square brackets, call underscore num, close square brackets parameters. Row underscore num is an optional parameter and is the row in the table array where we need to find the value. Call underscore num is also an optional parameter and is the column in the table array where we need to find the value. An important thing to remember is that either the row underscore num or the call underscore num needs to be there. If row underscore num is not present, we need to have a call underscore num, and vice versa. To return a reference for a specific value, we have equals to index, open parenthesis, reference, comma, row underscore num, comma, open square brackets, column underscore num, close square brackets, comma, open square brackets, area underscore num, close square brackets, close parenthesis, where reference is a reference made to one or more cell ranges. Row underscore num is an optional parameter and is the row in the table array where we need to find the value. Call underscore num is also an optional parameter and is the column in the table array where we need to find the value. Area underscore num is also optional and selects the range in the reference area. This range will help us return the intersection of row underscore num and column underscore num. The area that is selected is numbered 1 and anything after that is numbered in ascending order. If this value has not been set, it will default to 1. Implementing the index function. The implementation of this function can be classified into 4 basic types. 1. Using the index function to return a value from a specific cell. Step 1. Create an Excel spreadsheet containing the columns serial number, cost/kg, and vegetables like this. Step 2. Use the index function to find the cost per kilo of the vegetable French beans. The syntax for the index function is given here as equals to index, open parenthesis, A2 is to C11, comma 7, comma 2, close parenthesis. When we compare this value to the generic format we've seen before, we conclude that A2 is to C11 is the array parameter. It encapsulates all the data present in the table. 7 is the row underscore num parameter, which is the row number for French bean. 2 is the call underscore num parameter, which is the column number for cost per kg for each vegetable. Remember, We can make this dynamic by using the match function. We shall learn more about the match function further on in this lesson. 2. Using the index function to return an array value from a cell range. Assuming we want to know the cost per kilo and the name of the vegetable corresponding to row 2, how do we do that? Step 1. Let's use the previous example to understand this. Simply vary the syntax of the index function. Observe how the call_num parameter has been made 0. This gives us a horizontal range. Step 2. Let's try the same for a vertical range. This time around, change the row_num parameter to 0. This gives us the cost per kilo for all the vegetables on the list. Remember to use this as an array formula by using the Ctrl+Shift+Enter keys. Without this, Excel will not accept this as an array formula and will return a pound value error. This can also be used to extract values from a matrix. 3. Using the index function to reference a cell from a cell range or ranges. Let's use the previous example of vegetables and their corresponding cost per kilo. Now, as we're dealing with references, we need to make sure we're using the right syntax for the index function, which is this. For an array of reference cell ranges, we need to use this format. For this case, area_num for A1 is to B5 would be 1 and D5 is to H9 and so on. Let's implement this right away. Here we've defined 3 reference cell ranges. The first one is A1 to C4. The second one is from A5 to C8 and the third one is from A9 to C11. This clearly outlines 3 area_num. The row number in a particular cell range is 2 and column number is 3. Let's try varying the area_num value to understand this better. Let's change the value to 1. Potato clearly lies in row 2 and column 3 for the cell range A1 is to C4. That concludes the basic working and functionality of the index function. Let's move on to the match function. What is the match function? The match function is used to find the location of a particular value in the table_array. It returns the reference number for a cell rather than the value. We've already learned about the match function used along with VLOOKUP in a previous lesson. Match function with VLOOKUP. The syntax of the match function is this, where the lookup_value is the value we want to find and is a required parameter. Table_array defines the cell range we want to look at and is a required parameter. Match_type defines the type of match you want. This is an optional parameter. The possible values are 0, 1 or -1. If undefined, Excel assumes this to be 1. Let's understand what each of these values stands for. 0. Match returns the column or row reference for an exact value in the table array. 1. Match returns the column or row reference for the largest value that is equal to or less than the lookup_value. -1. Match returns the column or row reference for the smallest value that is equal to or greater than the lookup value. Applying the match function, since we know that there are 3 different cases for match type, we shall implement the match function using all 3 cases. 1. The match_type parameter is set to 0. When the match_type parameter is set to 0, the match function returns the column or row reference for which we are looking for an exact match in the table array. Step 1. Select a suitable lookup_value. In this example, the text value vegetable will be the lookup_value written into cell E6 that we shall call in the match syntax. Step 2. Using match to find the lookup value in the table array from A1 to C1, the syntax for match, which can be written as this, which returns the column reference number 3. 2. The match underscore type parameter is set to 1. When the match underscore type parameter is set to 1, the match function returns the column or row reference for the largest value that is equal to or less than the lookup value. Step 1. Select a suitable lookup underscore value. In this example, the numerical value 24 will be the lookup underscore value that we shall call in the match syntax. Step 2. Using match to find the lookup value in the table array from B1 to B11 can be written as this, which returns the row reference number 5. 3. The match underscore type parameter is set to -1. When the match underscore type parameter is set to -1, the match function returns the column or row reference for the smallest value that is equal to or greater than the lookup value. An essential step to avoid errors when using match underscore type is to make sure the values in the table array are in the descending order. Let's use the same example as before, but not arrange the values in descending order to see what we obtain. Use this, where 24 is a lookup underscore value, B2 is to B11 the table array, and -1 is the match underscore type. We obtain a #NA error. Let's now do this the right way. Step 1. Arrange or sort the data in descending order using the sort option in the drop-down menu. Step 2. Select a suitable lookup underscore value. In this example, the numerical value 24 will be the lookup underscore value that we shall call in the match syntax. Step 3. Using match to find the lookup value in the table array from B1 to B11, the syntax for match can be written as this, which returns the row reference number 6. Now that we are familiar with both the match and index function, let's learn how to use them together. The index match function. While both index and match are individually powerful functions, using them together has many advantages. In this part of the video, we're going to use them together to obtain the lookup value from the left side of the table array. You must wonder why we want to look for values on the left side of the array. This is simply to overcome the drawbacks of the VLOOKUP function that only returns value from the right side of the table array. Before we dive headfirst into the implementation of this function, let's understand what it actually is. What is the index match function? First things first. Remember that the combination of the index and match functions, which gives us the index match function, is one of the most powerful lookup functions present in Excel. It has replaced the VLOOKUP function for many use cases. One of the biggest advantages of the index match function is that it allows the user, that's you, to look up a value in the table based on both row and column references, either individually or using both at the same time. The syntax for the index match function can be vaguely written as this. Here, observe how the row number of the index function will be obtained using the match function. Now that we have a basic understanding of the index match function, let's put it to use by carrying out a simple implementation of the same. Implementing the index match function. Let's use the index match function to find the seller based on the type of vegetable. The aim of this example is to show how to look up a value from the right side of the table array and return a value that lies in the left side of the table array. Step 1. Create a table containing 3 columns of data. Column 1 is seller, column 2 is cost per kilo, and column 3 is vegetable. Step 2. create an answer table that contains two columns, vegetable and seller. Step 3. Using the index match function along with the lookup value from the answer table, we shall obtain the name of the seller. The syntax of the index match function is this. Upon comparing this with the generic form of the index match formula, we can conclude that A2 is to A11 is the array parameter from which the index function will return the value. The row_num parameter is given by the match function. Here, E6 is the cell containing the lookup value. C2 is to C11 is the array where the lookup value lies. 0 is the match_type, which means that we are looking for an exact match. Let's put this to the test. The lookup value in the answer table is coriander. This gives us the answer, Sonu, who is the seller of coriander. You are welcome to try multiple variations which may include a different lookup value, checking the cost per kilo, or using both row and column references in the index match function. This concludes the basic understanding of the index and match function in Excel. We also learned how to use a combination of the index and match function to look up values at the left side of the table array.